Hello viewers, today we shall learn about decision theory. Introduction. A decision is a process of selecting an alternative course of action given that at least two alternatives exist. The basic aim of decision theory is to provide a method of natural decision making wherein data concerning the occurrence of different outcomes may be evaluated to allow the decision makers to identify the best course of action. Course of action or acts. A decision is made among a set of defined alternative course of action. These are also called actions, acts or strategies and are under control and known to the decision maker. For example, consider a situation where a shopkeeper has to decide how many units to be stocked, given that the demand is of minimum 40 units and maximum of 80 units. The course of action for shopkeeper will be stocking 40, 41 and so on 80 units. States of nature, also called as an event. Outcomes of any course of action are dependent upon certain factors beyond the control of the decision maker. These factors are called states of nature. For example, in the above situation of stocking units for a shopkeeper, the states of nature will be the actual demand of units. Demand of units is uncertain and beyond control. Payoff. For each combination of an act and states of nature, there will exist an outcome. This outcome may be quantified in terms of monetary value. This outcome of act-event combination is called payoff. The general form of a payoff matrix is shown below. You can see on one side there are states of nature E1, E2 so on up to EM. Course of action are A1, A2 so on up to AN. A11 is the value of the payoff, which is called a payoff value for E1 and A1. A12 is again the payoff for action A2 and the states of nature E1 and so on. We can go up to AMN. Steps in decision theory. The process of decision theory involves the following steps. Number 1, list all possible future events called the states of nature which can occur in the context of the decision problem. Number 2, identify all the course of action which are available to the decision maker. Express the payoffs resulting from the combination of course of action and states of nature. Choose from among the given various course of action on the basis of some criteria that results in the optimal payoff. Now, types of decision making. Decisions are based upon the data available about the occurrence of events as well as the decision situation. The types of decision making environment. 1. Certainty, uncertainty and risk. A. Decision making under certainty. Decision making under risk, there are three methods in that. Expected monetary value called as EMV, expected opportunity loss called as EOL, expected value of perfect information, we can also call it as EVPI, and C. Decision making under uncertainty. We will start with decision making under certainty. In this case, the decision maker has a complete knowledge of the outcome of every course of action with certainty. Clearly, he will select an act that will give the largest payoff for the known state of nature. Now, decision making under risk. In this case, the decision maker has less complete knowledge with certainty of outcome of every course of action. This means there is more than one states of nature and for which the decision maker knows the probability with which each states of nature will occur. Number 1 now in this method, expected monetary value EMV. Expected monetary value for a given course of action is the sum of the weighted average payoff, which is the sum of the payoffs for each course of action multiplied by the probabilities associated with each state of nature. In formula, you can say EMV AJ is equal to summation Aij into Pi, where Aij is equal to payoff associated with states of nature Ei and course of action Aj. Here Pi is the probability of occurrence of states of nature. Ei, the course of action for which the EMV is maximum, is recommended. Now, expected opportunity loss EOL. An alternative approach to maximizing EMV is to minimize the expected opportunity loss, also called as expected value of regret. The EOL is the difference between the highest payoff for the states of nature and the actual profit obtained for the particular course of action taken. EOL is the amount of payoffs that is lost by not selecting the course of action that has the greatest payoff for the states of nature that occurs actually. EOL of Aj is equal to summation Lij into Pi, where Lij is equal to opportunity loss associated with the states of nature Ei and course of action Aj. Again, Pi is the probability of occurrence of states of nature. Ei, the course of action for which the EOL is minimum, is recommended. Expected value of perfect information, it is also called EVPI. In decision making under risk, each state of nature is linked with the probability of its occurrence. However, if the decision maker can acquire perfect information about the occurrence of various states of nature, then he will be able to select a course of action that yields the desired payoff for whatever state of nature that actually occurs. EVPI represents the maximum amount of money the decision maker can pay to get this additional information about the occurrence of various states of nature before a decision has to be made. So, we can say EVPI is equal to expected value of perfect information under certainty minus expected profit without perfect information. So, the formula comes to EVPI is equal to summation Aij into Pi minus maximum EMV, where Aij is equal to best payoff associated with the states of nature Ei. Again, Pi is the probability of occurrence of states of nature Ei. And the last, decision making under uncertainty. In this case, the decision maker is unable to specify the probabilities with which the various states of nature will occur. There are 4 different criteria we can use in this: Maximax or Minimax criterion, Laplace criterion, Hurwitz criterion, or criterion of regret, which is also called Savage criterion. Let us understand with an example. A person has 3 alternatives open to him, each of which can be followed by any of the 4 possible events. The payoffs in rupees for each action event combinations are given below. You can see the table now. The alternative actions X, Y, Z, and here they are A, B, C, D. So, 8 represents that if action A is taken and the course of nature is X, then it plus 8. Same way, if I take minus 4, then if action is A and the states of nature is Y, then it is minus 4. So, that much is a loss to it, and so on. We can understand the whole table. Question is, determine which alternative should the person choose if he adopts number 1 Maximin criterion, number 2 Maximax criterion, number 3 Hurwitz criterion if the degree of optimism is 0.7, Laplace criterion, and Minimax regret criterion. Solution. For the given payoff matrix, the minimum and maximum payoff for each alternatives are given below. So, the same table you can see, alternatives are X, Y, Z. The maximum payoff for alternative X is 8, for alternative Y is 18, and for alternative Z is 14. Same way, the minimum payoffs for X is minus 10, for Y is minus 4, and Z is 0. Now, the last column is alpha multiplied by maximum plus 1 minus alpha multiplied by minimum. So, the answers for each alternatives comes to 2.6, 11.4 and 9.8. So, now we will start with the number 1, Since alternative Z yields maximum of minimum payoffs, under maximum criteria, alternative Z should be chosen. Number 2 now, since alternative Y yields maximum of maximum payoffs, under max criteria, alternative Y should be chosen. Since alternative Y yields maximum value of alpha into maximum plus 1 minus alpha into minimum, under the Horwich criteria, alternative Y should be chosen. And number 4, that is for the Laplace criteria, we shall obtain average payoffs for each alternative. That is for alternative X, we know the payoffs values are 8, 0, minus 10 and 6. So, if we take an average 8 plus 0 minus 10 plus 6 whole divided by 4, it comes to 1. Similarly, for alternative Y, it comes to 6. For alternative Z, it comes to 7. Under Laplace criteria, alternative Z should be chosen as it gives maximum value of the average payoffs. And the last, for regret table, the regret payoff is equal to maximum payoff for each event minus the payoff of corresponding event. And this is the table that we get of the regret table. The highest value for A was 14. So, 14 minus its payoff 8. So, 14 minus 8, it comes to 6. 14 minus 4, it comes to 18, and so on. We get the whole table. Since alternative Y and Z both correspond to the minimal of the maximum possible regrets, the person should choose either of these two. Let us take another example. The demand for a product is given below. The different demand values are 40, 45, 50, 55, 60 and 65 with its corresponding probabilities. The product costs rupees 60 per unit and sells at rupees 80 per unit. If the units are not sold within the season, they will have no market value. The question is now, determine the optimal number of units to be produced. Also calculate EVPI and interpret it. Now the solution. The cost of the production is rupees 60 and the selling price is rupees 80. So, profit of it is sold is equal to 80 minus 60 is equal to rupees 20, and loss if unsold is equal to rupees 60 per unit. Now this is the main table. The first column is the demand 40, 45, 50, 55, 60, 65 as it is given in the data and its corresponding probability. The strategies now will take the same values of the demand 40, 45, 50, 55, 60 and 65. Now how this 800 comes? 800 is the amount that a person receives for selling 40 units. So you can see he purchases 40, sells 40. So 40 into 20 it comes to 800 rupees, and so on for all strategies values of 40 it remains 800. Now for 45, strategy 45, that means he purchases 45 units and correspondingly you can see he is selling 40 units only. So purchased 45, sold 40, so there will be a profit of rupees 500. And similarly, we can calculate for other values of for strategy 45, and same way we can calculate the table for other strategies also. Since the EMV is highest with 45 units, the optimum number of units to be produced is 45. Now expected profit for perfect information, which we call it as EPPI, which is equal to 800 into 0.1 plus 900 into 0.2 plus 1000 into 0.3 plus 1100 into 0.25 plus 1200 into 0.1 plus 1300 into 0.05, which comes to 1020. Expected value of perfect information EVPI. This is equal to EPPI minus maximum EMV. Now we have seen here that EPPI value is 1020, and from the table we have seen that maximum EMV is 860. So the answer comes to 160. Let us summarize the whole chapter. Course of action, acts. A decision is made among a set of defined alternative course of action. These are also called actions, acts or strategies. States of nature or event. Outcomes of any course of action are dependent upon certain factors beyond the control of the decision maker. These factors are called states of nature. Payoff. For each combination of an act and states of nature, there exists an outcome. This outcome of act-event combination is called payoff. Types of decision making. Decisions are based upon the information data available about the occurrence of events as well as the decision situation. The types of decision making environment: certainty, uncertainty and risk. Decision making under certainty. In this case, the decision maker has the complete knowledge of outcome of every course of action with certainty. For decision making under risk, there are three methods: expected monetary value, that is EMV, expected opportunity loss, EOL, expected value of perfect information, EVPI. Decision making under uncertainty. In this case, the decision maker is unable to specify the probabilities with the various states of nature that will occur. There are four methods in this: Maximax or Minimax criterion, Laplace criterion, Hurwitz criterion and criterion for regret, which is also called as a Savage criterion. Thank you.